Okay, so part 2 of chapter 1. We talked about the benefits of microbes. Now let's talk about the downside. So, most of the microorganisms that are around and the ones that interact with humans don't really hurt you in any way, shape, or form. But there are some bad ones out there that cause disease. Now, when a microbe causes a disease, we call it a pathogen. Okay, so when you hear something is pathogenic, it means that it's infectious. Okay, it will cause a disease in humans. So, the facts about pathogens and disease. The World Health Organization estimates that there are 10 billion new infections caused every year by microbes. The death toll from infectious diseases is approximately 13 million people per year worldwide. Yeah. New infectious diseases, emerging infectious diseases, continue to make themselves known to the world. Um, Before 1960, there was no such thing as HIV. Ebola didn't come around, I think, until the 70s. COVID has been around, but the specific strain COVID 19 didn't come around until 2019. So there are emerging things that you have to remember that things mutate, things change. That's one of the reasons why flu shots get changed up every year and you have to get it every year because there are so many strains of the flu that one shot wouldn't cover them all. What basically happens is we go in and we get the shot for maybe the top 10 they think is going to be the most prevalent that year. Now, if you happen to get one that isn't in that top 10, then yeah, you'll get the flu even though you got the flu shot, but it's a different strain than what you were actually inoculated against. Okay. Older diseases are also reemerging due to antibiotic resistance and increasing immunosuppression of certain populations of humans. Cancer patients, organ transplant recipients, and the elderly. So, antibiotic resistance is actually a really bad thing. It basically gives the bacteria, the bacteria, an advantage that allows it to somehow survive being exposed to that antibiotic. Now, the scary thing about antibiotic resistance is that it doesn't necessarily have to be a bacteria that is specific to that antibiotic that carries the resistance gene, giving it to the one that does. They exchange genetic material all the time, and getting antibiotic resistance means that we have to come up with something new to treat this disease that was easily treated by penicillin, let's say. With the advancements that we have in the medical field, in understanding the medical field like we do, there are more elderly people than there have ever been because we have ways to treat certain diseases. We have ways to help alleviate the symptoms of certain diseases. So, with that in mind, we've got all of these older people. Now, older people's immune systems are not as healthy as younger people's. So, that's one really susceptible part of our population. That's why when the COVID vaccine came out, elderly were one of the first to actually get it because their immune system doesn't work as well. When people get transplants, one of the effects of that is that they are an immunosuppressive therapy for the rest of their lives. They can't go without it because it basically endangers them. Their body's immune system needs to be suppressed. It needs to basically be slowed down so that it won't recognize the organ that got transplanted. They will be on that forever. But ultimately, the result is that their immune system doesn't work as well as it should, as it should because we're intentionally making it not. They are also susceptible to diseases. They were one of the high risk categories that were the first to get the COVID vaccine as well. Cancer patients. So, when you have cancer and you start getting chemo. Chemo actually is kind of a balancing act. I'm going to give you enough poison to kill the cancer, but not enough poison to kill you. And push comes to shove, that balancing act does destroy some of your cells. That's why they lose their hair, because literally those are growing cells. So it causes their hair to fall out. Um, Push comes to shove, our immune cells are made fairly often. So that also is something that absorbs the chemotherapeutic toxin and dies. Now, it's not all of our cells. I don't want you to think that. Just those that are being created. So ultimately, you have somebody who's being treated with chemotherapy who doesn't have a great immune system because they're on chemotherapy. Okay. Some diseases once thought to be non-infectious have now been linked with a microbial cause. So, ulcers. I'm sure everybody has heard of having an, oh my, I have an ulcer. A lot of, well, not a long time ago. Sorry, my phone is on. I didn't realize that. Okay, so gastric ulcers, forever it was, oh yes, you need to change your diet, you need to take out spicy foods, you need to go on ahead and not have acidic foods, you need to have, a bland diet, make sure you drink milk, blah, blah, blah. Well, I want to say it was in the 80s, there was an Australian scientist who figured out that mice that had this disease, had ulcers, actually had a bacterial infection, H. pylori or Helicobacter pylori. Okay. He went, explained it. People were like, whatever. So, in order to prove it, he actually infected both him and his wife with H. pylori, and both of them got ulcers. Now, did we know that that was what was causing it? No, not for a really long time. But now that we do know that, it can actually be tested for. You can test for H. pylori, and if the person has it, you give them an antibiotic, and poof, they're cured. They don't have an ulcer anymore. Are all ulcers caused by H. pylori? No, just so you know. Chronic infections with bacteria or viruses have been linked to multiple sclerosis, obsessive compulsive disorder, coronary artery disease, and even obesity. So there are links between these things. Have they been completely proven? And not necessarily, but there are links being made. So most likely, with enough research, we'll figure out exactly how everything works. Okay, so if you look at the top causes of death in the United States or worldwide, you will notice that microbial infections are the cause of them. So, top 10 reasons for death in the United States. Number 8 is influenza and pneumonia. I'm sure that's changed now because of COVID. Don't get me wrong. And number 10 is septicemia. Septicemia is a very fancy way of saying there's an infection in the bloodstream. Either way, both of these are infections caused by a microbe. Now, worldwide, again, I know COVID plays a role in this, but because our book isn't the newest one, respiratory infections are number 4. Technically, COVID can be considered a respiratory infection. HIV and AIDS is number 7. Diarrheal diseases. My brain just left my head. Malaria. Tuberculosis is number 10. Tuberculosis is also a lung infection, but it does a lot more damage than, let's say, the common cold. It actually causes lung damage called tubercles, which actually we will touch on at the end of the semester. Okay, so let's talk about the early years. Back in the day, it was if I can't see it, you can't prove it, it doesn't exist. So back in the day, people had this belief that there were invisible vital forces, okay, present in matter that led to the creation of life. So basically, It was how new microbes were made. They spontaneously arose from mysterious vital forces in food, in wood, in garbage. You know how, you leave a slice of bread out, it gets moldy. Yeah, mysterious vital forces. So you had X-Men powers creating life, which doesn't exist. But at the time, think back, there was no way to prove that there was something there. Okay? It would be like me telling you that I have a unicorn named Pinky who is right behind me eating Skittles, and you looking at me like I'm crazy. Without any type of proof, without being able to actually see and prove that there's an existence of a unicorn behind me, you'd never believe me. Um, Even after the discovery of microbes, the theory of abiogenesis, basically life without life, like it just spontaneously came about, was still embraced by quite a few because they didn't understand. Okay. So, biogenesis is the belief that living things only arise from other living things of the same kind. Louis Pasteur proved this with his experiments, and this theory was correct. But how did he prove it? How did he show them that it just doesn't come from mysterious vital forces? It's actually a really simple experiment, but it's a really good experiment. So he had these things, okay, called gooseneck flasks, okay? So you've got a round bottom flask with the gooseneck. All right. So he put media, probably something like chicken broth, inside of this, and he boiled it. Okay. So the broth was sterilized to make sure it was free of organisms. So boil the holy tar out of it, make sure that there's nothing living inside. This is one of the reasons why we cook our food, because it kills microorganisms. So he took one set and broke the gooseneck off, opening it up to the air. But the second set, he left that gooseneck intact. Now, I say set because in the science world, you don't do one. Yes, I realize the picture is one, but you do this multiple times to prove it over and over again. Because if you can get repeatable results, then your theory makes sense. So, when he broke that and it was exposed to air and air could get inside, they saw growth. So, there was life coming into that broth. There was growth there. It went bad. However, the second flask where he had the gooseneck, think about it. If anything was going to get in, they would have to go down and then up and over to get into this flask. That's not going to happen unless you're like blowing into it. So, with the gooseneck intact, this stayed sterile. It's one of the reasons why once we autoclave something to sterilize it, we keep it closed. Because if we keep it closed, it stays sterile. So, if the neck was broken, contaminants from the air caused growth in the sterile broth. If the neck was intact, contaminants were actually trapped at the base of the neck and couldn't get to the broth, so there was no growth. So, again, this was proving biogenesis, that there had to be something there that started the growth. Okay, there's mold spores in the air that fall on that piece of bread, and it's from there that the mold grows. It isn't, oh no, it came from vital forces. No, there's actual physically something that comes, lands on it, and causes it. Okay, so important milestones in micro. So Robert Hooke, this is in the 1660s, studied household objects, plants, and trees using a very, very simple magnifying glass. So think of the old school, detective with the magnifying glass. But being able to make the image larger kind of helped him to see these objects better. Now, Leeuwenhoek, okay, that doesn't help. I hope you have your PowerPoint. Leeuwenhoek manufactured very simple microscopes. Autoclave just went off, sorry. Um, but he was actually a guy who worked in textiles. So he worked with fabric. And the only reason he made these originally was to be able to see the pattern and the weave in the fabric. So he wanted to be able to see the threads. But once he accomplished that, he used those same very, very simple, basic microscopes to look at animals inside of a drop of rainwater. He observed animalcules, molecules, animal, he combined the two words, straight from other people's teeth. He constructed over 250 small microscopes that could magnify up to 300 times, see the X, that's times, 300 times what your naked eye could see. So, Leeuwenhoek. Joseph Lister, no Listerine mouthwash? That was actually named after Joseph Lister. He didn't invent it, but it was named after him. His use of aseptic techniques in surgery in the mid 1800s was kind of groundbreaking. So, back in the day when people would go to the hospital, give me 1 second. Sorry, I needed water. Um, Back in the day when people would go to the hospital, you would get guys going into surgery that had been walking on the street. And if you think about back in the day, you used to have things like chamber pots that they would just dump out on the street. Horses drawing buggies would just crap on the street. So they're walking through that. If anybody touched anything, if you touched a wall, if you touched a door handle, there was a real good chance that it was contaminated with something. Well, men who were surgeons used to just walk into surgery just like that and just operate. Didn't wash their hands, didn't put on a mask, nothing. So the incidence of death was really, really high. Joseph Lister came up with wash your hands. I mean, of course, they didn't have latex gloves and things like that at the time, but washing your hands was a very big step and a huge step toward more of a sterile field for your patients. That was a huge leap in medical, and you're going to probably go, and it might not be the right word, but technology. The fact that it was a medical advancement that you washed your hands. Now, today, we obviously know, and with COVID, we obviously know we use hand sanitizer, we use soap. But at the time, it wasn't really common. In fact, bathing wasn't really, really common. So, Ferdinand Kahn, he is the one who discovered endospores. Um, Endospores are really important when it comes to sterilization, um, making of free life forms, and endospores are almost like a way for them to hibernate, make a hard shell, and protect themselves from, let's say, washing with soap and water. So discovering that this other form existed was huge because we knew we had to do more than just soap and water in order to actually get sterilization. Okay, Oliver Wendell Holmes and Ignaz Semmelweis um, are two other people that basically touted the importance of aseptic techniques in hand washing by physicians attending patients. So, aseptic techniques, basically antiseptic techniques. So, again, let's go back to in the day. In hospitals, they would often reuse bandages. Now, mind you, they wouldn't wash them, they would just reuse them. So, you had a guy who was dying of gangrene in bed one, and he finally dies, but you've got a guy in bed two who needs bandages. You just took him off of guy one and put him on guy two. If you had surgical instruments that used in surgery, scalpel, whatever, again, you would just go from patient to patient. You never washed your instruments. The idea that things could be on them didn't really exist. So these two, um, Holmes and Semmelweis, were kind of, again, like Lister, pioneers in the fact that they were very adamant you had to wash everything. You had to, sterilize everything. You couldn't switch bandages between patients. Um, it was a new way of thinking, and a lot of people didn't like it because it was expensive. Most doctors didn't want to spend the money to get fresh bandages, or they didn't want to pay somebody who could wash the bandages in between. And yes, I realize that's gross, but again, think about it was back in the day. This wasn't modern times. So the thought wasn't there. Thank goodness it is now. Okay, Robert Koch. He developed a series of postulates that verified the germ theory of disease and established a link between a microbe and the disease that it caused. So we'll talk about that in part 3.